So graphing rationals part 2, what do you do if it's in standard form as opposed to parent function form? Because you can't tell the transformation. So you have to gather, instead of the transformation, you have to look at your roots, which are your x-intercepts and your y-intercepts. So to find our roots, we are going to set the top of our fraction, or the numerator, equal to 0, and solve for x. To find our y-intercepts, we set x equal to 0 and simplify. Okay. Horizontal asymptotes are a little bit different in this one. We set the bottom equal. Sorry, that's vertical asymptotes. We set the bottom equal to 0. And then with horizontal asymptotes, we are going to look at a case statement. And our case statement is very peculiar. We are going to look at the exponent of the top versus the exponent of the bottom. So if the top is equal to the bottom, as in the exponent of the top is equal to the exponent of the bottom, then my horizontal asymptote is that y equals the coefficient of the top over the coefficient of the bottom. Okay? If the top is less than the bottom, so it means the bigger exponent is in the denominator, then my asymptote is going to be at y equals 0. If the top is larger, the exponent on top is larger than the exponent on the bottom, then we have no horizontal asymptote. We're actually going to have a slant asymptote, which they will go into in pre-calculus. Okay? Domain and range get a little tricky on this one. Okay? Your domain is everything except where the vertical asymptote is at, and the range is everything except where the horizontal asymptote is at. So now let's look at an example of this. We have a fairly simple function, so we're going to do the root first. We find our roots by setting the top equal to 0. So I'm going to take just the top of my equation, x minus 3, set it equal to 0. And I get x equals to 3. So I know that I have a root at 3, 0. Easy enough. 1, 2, 3, put a dot. Okay? Now I'm going to look at my y-intercepts. Y-intercepts say set x equal to 0 and simplify. So that means I have 0 minus 3 over 0 plus 3. Well, that would be equal to negative 3 over positive 3, which is negative 1. Okay? So that means I have a y-intercept at 0, negative 1. Go down there and put a dot. Okay, so now let's look at our horizontal asymptote. Horizontal asymptote, got to do the case statement. So highest exponent on top is 1. Highest exponent on bottom is 1. So I have the case where top equals to bottom. That means I have to look at my coefficients, leading coefficients. Well, what coefficient's in front of the x? 1. What coefficient's in front of the y is 1. So y is equal to 1. So at y equals 1, I have a horizontal asymptote. So I draw that in. Now let's look at the vertical asymptote. Vertical asymptote, it says set the bottom equal to 0. So in the bottom, the denominator, I have x plus 3. I'm going to set that equal to 0 and solve for x. So I subtract 3 to move it to the other side at x equals to negative 3. That means I have a vertical asymptote at x equals to negative 3. So I come over to negative 3 on my graph and put in my dashed line. Okay, I know my domain is going to be everything except where my vertical asymptote is at. So I can go ahead and write my domain as everything except where x is equal to -3. And my range is going to be everything except where y equals to +1. Okay, so now we can draw a curve. If we want to double check it, we could double check it by going into our calculator, plugging our equation into y equals, make sure you include your parentheses, and then looking at the graph just to double check. Make sure we know what our curve looks like. So yes, it does come down. It's going to go through both the x-intercept and y-intercept. And then it flips and goes on the opposite side. And that's the cool part about rationals, is it's always going to be opposites. If you have one on top, the next one's going to be on the bottom. If we had another one, it would be back up on top. And that's how you graph rationals.